Hi, welcome to Dark Dragon Does Math. We are reviewing for a test today. So I'm going to basically show you how to answer all these questions to the best of my ability for what I believe are the right answers, considering I wrote the test. I hope they are. And this should get you set up to take the test tomorrow. Alright, so first off, let's simplify each expression. So what we're going to do is we're going to basically combine like terms. That's all we're doing for these four questions. For this one, I'm going to start with 11a plus 3a. Think about that as 11 plus 3, that's 14. So 14a minus 7a. Well, 14 minus 7 is 7, so the answer there is just 7a. Here, this is a little bit more complicated considering we have fractions, but all we have to do is find a common denominator. I think it might be easier just to start with these two. So let's find a common denominator between 4 and 3. It's going to be 12. So something over 12x minus, because that's a minus there, something over 12. To make 4 into 12, I would have to multiply by 3, basically, what's on the bottom here. So 3 times 3 is going to be 9. To make 3 into 12, I'm going to multiply by 4. So 4 times 1 is 4. And so this is going to be 9 twelfths minus 4 twelfths. 9 minus 4 is 5. So that is 5 twelfths x. And I still need to do the plus 1/9. So plus 1/9 x. Common denominator again. If you don't know, you can always multiply 12 times 9. So if you were to do that, I believe the answer is that's 108, I think. But there's an easier one. 72 is also a common denominator, but the smallest one's 36. So I'm going to try 36. So 36x plus something over 36x. 12 to 36. 12 times 4, or 12 times 3 is 36. So I'm going to multiply that by 3. 3 times 5 is 15. 9 times 4 is 36. So I'm going to multiply that by 4. 1 times 4 is 4. And then I just add straight across. So the 36 stays on the bottom. 15 plus 4 is 19. So this is 19 over 36x. This one, I got z's and b's, so I want to make sure that I keep them separate. So I'm just going to do my z's over here and my b's over here. So I have 13.7 z, so I got that one. Negative 6.7 z. And then my b's, I have negative 6.4 and positive 7.4. So I'm going to put the bigger one on top. 7.4, negative 6.4. Okay, 13.7 minus 6.7. Well, the 0.7s are going to cancel out. 13 minus 6 is 7, and that was z, so 7z. 0.4s are going to cancel out here. That's going to be 0. 7 minus 6 is 1, so that's a 1b. So my answer is 7z plus b. Number four, I don't have to find common denominators, but I do need to make sure that I keep my so I want to keep my r's and my constants, so I'm just going to call those numbers. So my r's are 6/11 and negative 1/11. So 6/11 here, negative 1/11. Remember, I'm getting that negative. I'm capturing that negative with it. And my constants are 3/4 and negative 1/4. So 6/11 minus 1/11 is 5/11, and that's 5/11 r. 3/4 minus 1/4 is 2/4. Make sure you recognize that 2/4 can be simplified to 1/2. So the answer to this is going to be 5/11 r plus 1/2. So it's kind of combining like terms. Oh my gosh, I have not been writing that, so you can see. I'm very sorry. So we split them up, 6/11, negative 1/11, 3/4, negative 1/4. 6 minus 1 is 5, so that's 5/11ths r. 3 minus 1 is 2, that's 2/4, but that can be simplified into 1/4. And then I just make sure that I keep these separate. And just a reminder, if they're not the same variable, you have to keep them separate. It's like this right here, this is like zebras and bunny rabbits. They're not the same animal. This is a number and that's an r. They're not the same. Okay. If I want to expand, whoa, okay. My computer's acting slow and funny. So if I want to expand this, to expand is use the distributive property. I'm going to take this negative 3.3 and I'm going to multiply it by both of these terms. So I'm going to do negative 3.3 times 5. And remember, this is negative, so my final answer is going to be it's like 33 times 5, but it's negative and there's one decimal. One decimal right here. And then I'm going to do 33 times 2. But keep in mind, this one right here, that's negative 33 times negative, make that positive. So I don't want that to trip anybody up. 3 times 5 is 15, carry the 1. 3 times 5 here is 15, 16, so 165. It's negative 165, and there's one decimal place, so it's actually negative 16.5. 3 times 2 is 6. This had one decimal, but it was going to be positive because it was negative 3.3 times negative 2, so that became positive. So it's going to be 6.6. So the answer here is negative 3.3 times 5 is negative 16.5, and when you keep the p, and then negative 3.3 times negative 2 is positive 6.6. This one, same thing. I'm going to do it a little bit differently. I'm going to say 2/5 times m over 2 plus, for the plus sign in the middle, 2/5 times 2 over 7. And simplify it this way. I don't care which way you use on your actual test, you just got to get it right. Dadgummit, keep forgetting. So make sure that when you do this, 2/5 times m over 2, so 2/5 times m over 2 plus 2/5 times 2 over 7. So one of these two strategies is what I would recommend. So 2 times m is 2m, and then 5 times 2 is 10. Or you could just recognize, these two 2's, they kind of cancel out. So that becomes m over 2, not m over 2, m over 5. And 2 times 2 is 4, and then 5 times 7 is 35. So that's right there, as simple as it gets. That's the answer. When I expand that, I get m over 5 plus 4 over 35. For these factor problems, I'm going to factor that. Now remember, when I factor, I want to find the greatest common. So the greatest common factor between 9 and 36 is going to be 9. So I'm going to do 9. I'm going to do 9 over 9p plus 36 divided by 9q. So this becomes 9 on the outside, stays on the outside. 9 divided by 9 is 1p. 36 divided by 9 is 4q. And that one's done. This one right here, negative 21 and negative 7. The greatest common factor between those two is going to be negative 7. So negative 21 over negative 7 are minus 7 over negative 7s. So negative 7 stays on the outside. Negative 21 divided by negative 7 is positive 3. Negative 7 over negative 7 is 1, so that's going to become positive 1s. So both of those are done. We're going to write the expressions. We're going to write these as, we're going to translate the verbal expressions as math sentences, and then we want to simplify. So 5/6 y subtracted from 1/10 c. So let's work that. Let's start with 5/6 y. So I got here. Subtracted from. That means that there's something in front of it that is subtracting this. So I'm going to make sure I get that negative in front. 5 times, so that's 5 multiplied times 1/10 c. Okay, so now I just have to simplify. 5 times 1/10. Well, this would be the same thing as 5/10 C, and then I hope you recognize that 5/10 is the same thing as 1/2. So this becomes 1/2 C minus 5 6y. This one, 40% of the product, oh shoot. I have to tell everyone to change that to the sum. So hopefully I remember to do that in class. So 40% of the sum of 1/3 y and 4/15 c. So let's start with 40%. Remember, we write 40% as 0.4. 0.4 of the sum, that means 0.4 times, of means to multiply, times the sum, that means there's going to be something added. 1/3 y, 1/3 y, and that right there is what the plus sign is, 4/15 z. And if you get that, that's fine. You can honestly leave it like that. If you're feeling so inclined, you can distribute the 0.4. It gets a little hairy. Just so basically, the way I would do that if I was going to distribute is I'd write that as 4/10. Remember, this is 4/10, so I'd write it as 4/10. I want everything to be the same, either all fractions or all decimals, and I prefer fractions usually. So, and then I could distribute 4 times 1/3 is 4, or 4 times 1 is 4, 10 times 3 is 30, so 4/30 is y, 4 times 4 is 16, 10 times 15 is 150 z. So you can do this, any of these, this answer is fine, this answer is fine, it doesn't matter which. You'll probably end up choosing that one, but I just want to show you distributing there. On the back, a shirt costs $9.50. Let's get this amount. A shirt costs $9.50 and a pair of pants costs $12.70. Jessica bought 8 pairs of pants. She also bought 3 more shirts than she did pants. Write an algebraic expression for the total amount she spent. So she has 8 pants. Remember, pants are $12.70, so the total amount of money she spent on pants is going to be 12.7. I'll write 70 for now. So 12.70 H. That's how much pants. She also bought 3 more shirts than pants. So shirts is going to be H plus 3 because she bought 3 more times $9.50. And then we want to simplify all this and add it to one price, so it's just one small expression here. So let's distribute the $9.50. So that and I'm going to cut out the 0 here. So this is going to be 9.5 H plus 9.5 times 3. Well, 3 times 5 is 15. Carry the 1. 3 times 9 is 27. Plus 1 is 28. So that's 28.5. We still have the 12.7 here. So, and now I just want to combine the two H's. 12.7 plus 9.5. 12.7 plus 9.5. Well, if that was plus 10, it would be 22.7, but it's just less than that, so it's going to be 22.2 H plus 28.5. And don't forget, this is a word problem, so it's going to have a unit. So when we simplify it, 22.2 H plus $28.5 is how much she spent. So depending on how many pants she bought, that'll change the amount of dollars she spends. Joe gets paid $7.50 an hour in time and a half, basically 1.5 times that amount for overtime. He works Y regular hours and W overtime hours in a week. So write an algebraic expression for Joe's weekly wages. So $7.50 is a normal, So I'm going to write 7.5 for a normal hour of work. And then overtime hour of work would be regular is Y. So overtime W is going to be 1.5 times 7.5. So 1.5 times 7.5, that's 11.25. So if he works Y amount of hours, so 7.5 Y plus 11.25 W. And that is his weekly wages in dollars. Think of it, and this is just for those of you who don't know, you work 40 hours a week, and that's standard, and then every hour after that is overtime. So he might work no overtime hours. You might work 10. So if you worked 50 hours in a week, you would work 40 here and 10 there. But anyways, that's kind of, once you get a job, you'll worry about that. But that is the expression for the amount of money you would make in a week. And if we wanted to factor the expression, we would take out, basically we got paid $7.50 here, so we know that $7.50 goes into both, so we could say 7.5, pull that out, Y plus 1.5 W. And that's just going back to what is the greatest common factor. We already, there's 7.5 here, 7.5 there. So find the perimeter and the area of the rectangle. Okay, so let's do area first. I think it's a little bit easier. Area is going to be 7 times 3x minus 10, which becomes 21x minus 70. 7 times 3 is 21, and we keep the x. 7 times 10 is 70. And don't forget to write units squared, because anytime we have something that doesn't tell us the units, we still want to, whoever's grading our test, to understand that there is a unit there, we just don't know what it is. For the perimeter, we have to add everything together. So this is going to be 7, this 2 is 7, this up here is 3x minus 10. So we're going to add everything up. So I'm going to add the two x's first. 3x plus 3x becomes 6x. 7 plus 7 is 14, and then negative 10 minus 10 more is negative 20. So let's add those two together. We get 6x. 14 minus 20 is negative 6. So 6x minus 6 units. All right. David and Denise share Q oranges at a ratio of 3 to 8. How many oranges does David have in terms of Q? So the way I'm going to do this is I take, how many oranges does David have in terms of Q? So we have 3 to 8. And this is David. Here, let's write that bigger. David has 3. Denise, she has 8. We know that because they come, David comes first, then Denise. 3 comes first, then 8. So how many does, together, there are Q. Alright, so because they share Q amount of oranges. Together there are also 11 parts. That's as simple as just saying 3 plus 8 is 11. So how many oranges does David have in terms of Q's? Well, David has 3 of the 11 total parts of Q. And that thought process, basically what it's saying is David has, we don't know how many there are. There could be 11, there could be 1,000 and 100. Down here that we learned that there's 44. But basically we take, he has 3 11ths, because altogether there's 3 11ths of however many oranges they have. So if we take this, how many oranges does David have? How many pairs does Denise, oranges does Denise have? Alright, so we say if Q is 44, so we say 3 11ths times 44. Basically, we switch out the q with the 44 here. So 3 times 44, we don't necessarily have to do that. You could say that 44 divided by 11, that's easier. It's 3 times 4, which is 12. So if there were 44 oranges, David would be getting 12 of them, and Denise would be getting the rest. So David has 12 oranges. Denise, well, she's equal to 44 minus 12, which is 32. All right. Which makes sense because 3 times 4 is 12 and 8 times 4 is 32. Finally, Danny waited 1/3 of a minute at her bus stop. Okay. The bus took 2m minus 9 minutes to get to school. And after school, she walked for 13 minus m minutes to the Boys and Girls Club. How long was Danny traveling? All right, so we're going to say she waited for 1/3 m minutes. Took that long, so we're going to add that 2m minus 9, and then she walked another 13 minus m minutes. So when we add all this up, I want to add the m's first. Okay? So I have 2 plus 1/3 minus 1. So 1/3, 2, that's a negative 1. And that's m. 2 minus 1 is 1, so this is 1 plus 1/3 m. So you could say that is 1 and 1/3, or if you're so inclined, that is 4/3 m. And then the numbers themselves, I have negative 9 and positive 13. So 13 minus 9 is 4. So 4 and 4/3 m minus 4 minutes. That is how long she was traveling. I hope that wasn't sloppy enough, or wasn't too sloppy, but that's me going over it. I hope you didn't watch this till after you did it yourself at least once, but test is tomorrow. I'll talk to you guys later. Have a good day. Sorry guys. Math!